Hi, now we come to one of the very important concept for signal and system, because this is a very important concept for all the remaining lectures, especially for the convolution and how to model that. So I like to use the video to record that so that you can go back home to watch it as many times as you can to understand it. Now, first, I'd like to talk about the impulse function. The impulse functions. T. Then that one is equal to 1. So this one is delta t. So what it means that impulse function, we have a signal with a magnitude that is equal to 1 when time is equal to 0. That is what impulse function is about. Okay, of course, if you remember, another very important concept is delta t minus t naught, and this one is t naught. Okay, so we simply if we have delta t minus t naught, we shift the t axis here by t naught, so the axis become here, so delta t here. So this is what it is. Now this is very important because we rely on shifting the axis. Suppose we are going to have delta t plus t naught, and this time it will become, we shift the axis that. So we are going to have 1, that's t naught. Now, so we can actually, by shifting the t naught by minus t naught or positive t naught, to move the function to here or to there. That is very important. Now, because of that, another very important concept is, I like to use this thing to explain it to you. Suppose we have a function here, there's xt, and time is equal to 0 here. Okay, then if xt multiplied by gt, what gt is about, if gt only exists here, okay, xt minus gt, xt only exists here 1 times xt, then we only have, that's the answer, that is xt times gt. This one is here. Suppose if gt is not here, okay, I rub it out. Suppose that's what gt is about. Okay, so this one is t naught. Okay, we can simply consider this one is delta t minus t naught. Then this xt time gt or xt time delta t over t naught just equal to these particular things. And this one is equal to that one. Okay, that is very important. That is very important. Okay, so what you can see is we come to this particular equation here. This particular equation is also called the shift length property. shifting property. So what does it mean? Now, we try to integrate that. What does integrate that means? Integrate this one multiplied by this one. It means the signal of this multiplied by that, another signal that 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 multiplied by that. Then we put them all together. Integrate this one, that. So if we are going to consider that they are continuous, then we are going to get exactly the same signal here. But coming back here, we are going to have not this one. We are going to have a very simple thing. Delta t minus t naught, just this one. Integrate that, which is equal to this one. Then we try to sum all other thing. But is there any other signal there? None. There is none. We try to sum that, but none. Because this signal is just delta t minus t naught. There's this one minus this one. Just only this one exists here. So what we will get is just only this one. So if we are going to consider this particular case, xt times delta t, that is delta t minus 0, that is the delta function here. So we got exactly the function at 0 here. Okay, this is the shifting property. Because of that, we can simply, just like here, to replace this t naught by t, just like this k here. So if we replace this big T here, so that will become delta t minus t. So the function just like that, that is big T. So we will get xt here. This is the case. So once when we understand this concept, the next concept is we have a function here. This time we are going to shift it also by t, shift it by t. So we are going to replace this j omega t, ej omega t, then becomes ej omega t, because it only exists at t, just like it exists at t here. So this is the property here, very, very important.